the sea migrated to northern part. So, and we have condensed section in Nautilus Formation. How 283 meters of basin deposited in Kirkuk area. I mentioned earlier, and nobody, I didn't get back anything from anyone about basin and this one. Second one about biomarkers. Why we ratios between biomarkers didn't give us better than comparing peaks, because biodegradation and weathering and some other stuff. Maybe change some data. Ratio, for example, Hopkins, terrain compared to 328, 436, or any for biomarkers, we get data PM from them. But peaks give us directly. So just I wanted the point why we get to peaks directly, not going to ratios.
The clusters are there.
Yeah, well, that's yes.
Yeah. Just I make quick.
Okay, thank you
The
very
third
much.
one. About the source rock correlation, maybe we use also some evidence from Tepping to indicate carbonate source rock or shale or Mars, and then with strategic methodology also. If we have same correlation, that we.
Sorry. Thank you, Carlos. Carlos, yeah, you mean, sorry. About the bursary, okay. This question is about bursary. Bursary, you know, it's mostly stromatolitic, so it's a very good indicator of stromatolite from bursary to Chiagara Formation. And fortunately, one of our colleagues working on these sediments here, before me. So the boundary is when you finish the stromatolitic limestone, you will begin the Chiagara Formation. About the biomarkers, yeah. If you know, I calculated these biomarkers from the area under the peak, not quantitatively, as you know. If you want, as you said, that every peak you will get some concentration. So you will. It's another word quantitatively. You should add standard and a quantity. For example, 1 microliter from 4 alpha standards, for example, and later on you will find it. But the ratio between these compounds are also acceptable, as you know, from the geochemical points of view. Yeah, it's true. I didn't mention too many parameters or many results from the biomarkers like the saturation, soil maturation, like the type of organic matter, if you have evaporates, anything. Yeah, there are many. But just I'd like to explain the correlation or something using biomarkers.
Thank you. It's something to explain for our SC members. When I came back from Germany, they told me about source rocks. They have total QOC 1 to 6, 7%. I was very surprised because in Germany I saw source rocks, for example, Duttenhausen. It was only 12, 13 meter thickness. We had percent of sometimes 35%, 40%. That was source rock. It was not. I don't agree with this time. I don't agree with that 5% source rock. But if you know the thickness here, sometimes 1 kilometer thickness, and you have 5%, the mass is too much. This is source rock. But I don't believe all the source rocks, what we say in Kurdistan, source rock is source rock because our institution, our organic geological investigation about that, you must have organic geological, you must have some bituminite, it's special for the source rock. Sometimes we have not bituminite. We have derivatives from bituminite in the source rock. And then I think upper Triassic, lower Jurassic, mid Jurassic, they are source rock. I can prove it geochemical and organic geological. But I don't think, I'm sorry, I don't know. I don't think that upper Jurassic or tertiary source rock.
Sorry, you
I
didn't.
don't think that Upper Jurassic and Tertiary, they are so small. I don't think it's only migration from oil and come down.
All these data
Okay.
indicators.
I can prove that in the next years because I'm very sure organic ecological, I can prove it that lower Triassic, upper Triassic and lower Jurassic, middle Jurassic from Kurdistan is 100% sulfur with alginite, with several types of alginite and bituminite. And I don't saw any alginite, real alginite in upper Jurassic. I saw only some bituminite, from alginite. It is maybe comes from oil. I don't know. In Common Formation, we have some alginite, but it's not really so much. We can speak about some source of layers there, but as package to say this is source of formation, no. I can see circular formation is source of 100%. Chiakala, some parts here. Balut, really, but I can see Common Formation is source of formation. Thank you.
We hope also for Lower Jurassic to be studied geochemically or from this point.
Thank you. I will also have a
Yeah, سمير.
Thank you, Dr. Ryan. Dr. Ryan, it is clear that Amreen is definitely different story. From GOC content point of view, from beta-beta open, from the stearins, from the high sulfur content, even from the aromatic parts within the material terrain. And the depth also is deeper from all. Well, what's your interpretation for such condition?
In my study, we concluded that mostly it will depend on the maturity from the isotope. Yeah, we know the depth is
deeper.
Yeah, it's deeper, you know. But the biomarkers for maturity is not very good elucidated. So that's what. Other things may be other reasons. Really, I don't know exactly what's happened, but yeah, it is a different story with other rock.
Do you not think that the high TOC content in the other sections has effect on being the output of your peaks of the GC or GCMS be different? Because when it becomes very low, it affects.
Yeah, it's true.
But if it is too high, what about that?
It's true, but it's true. We mentioned, I didn't mention, sorry. It is better to use the sample for GCMS analysis to be more or larger, or the TOC should be large or more than 1%. 1% TOC. So that's what we select from the samples. All are more than 1% TOC.
So I did to answer me and
I don't know about gamma-sling and olein in oils in Kirkuk oil field. We have K247 and K239. I found olein 0.8.
Olein,
Olein.
which is related to tertiary.
Tertiary,
Yeah.
so 0.6 cretaceous. More than 0.6 tells you it's tertiary. So I found 0.8. That's number one. So in southwestern Iran, we have Beda and Amiri formations, which are very good source waters. And a few hundred kilometers, we are far from.
A few hundred kilometers.
Yeah.
Yeah.
So it's not too many for oil migration or source rock
Characteristic.
situation, you know, to get it mature. But what we have here in the southeastern part of Kurdistan, we don't have thickness of 2,000 meters with very tertiary rocks to get mature.
Yes.
And when we found gamma-sling tells us lower Jurassic. But when I don't have gamma-sling, and I have only some other stuff. I went to Upper Jurassic.
Gamma serine also related to economic facies. Gamma serine is most related to evaporate.
It's a hyperserine environment.
The hyperserine.
Okay, thank you, Dr. Rahim. Thank you. I have only 15 minutes to show you our institute, please, and on 1 o'clock we have lunch, okay? Would you like to come with me and show you our institute? Okay, thank you.
Maggian, selamı. Ega kapına da. Ay şu an. Maşallah la kurra fazla. Akar. Lete,
Please. Okay, Dr. Andres Morzinos is also a co-geologist, member of ICCP, with Peter in Australia. Please. Hello.
I'm going to present something premature, like a pit. After lunch, we have to be more light. So I will present coastal asphalt fan in Keri, Zakynthos. It's in Greece. Keri fan is located in the southwest part of Greece, in the island Zakynthos, here in the southern part. You can see it's a fan, it's a coastal fan. It's 1 kilometer square. And it's well known from Herodotus' time. As you see here, it's for 2,500 years known, this fen. It's known because there are asphalt springs. I can show you here. There are some lakes here, some small asphalt springs. There are some photos. Here is a well that was used during the World War II from the Germans and from some English company up to 1980 was producing. And you can see here is the asphalt lake and some more detailed photos. This for the history. The ancient Greeks were using this asphalt, and they was taken outside from the ports, and they were using for the ships to isolate for the ships and make them for them to ship. They isolate when they construct the ship. They isolate it in order not to sink. So the geology of the area, it consists mainly from Miocene limestones and in the upper milestones, sandstone, marls and shales. They are located here and there. And the Kerik Fen is a tectonic depression. They are east-south faults and made this fen. Also, we made a helophytic vegetation map. So our field work was started 1996 and 1999, and is continuing, I think, up to now with many masters and some of PhDs. We done the helophytic vegetation map. Is you can see here. We discriminate the vegetation. So we found vegetation, Kiperaceum from Mictes, Sciurus, Yoncus, and here are the springs that we locate. And somewhere here it's this Herodotus spring. We've done during these times that we working there, 17 hand-driven cores, as you see here. And this is a pit sample. It's a half meter. And we made some samples, sample laboratory testing, proximate analysis, botanic analysis, some palynological determinations, geochemical mineralogical analysis, and radiocarbon dating. So this is a cross-section of the Kerik Fen. This is a pit formation. This is a limnic clay, clay mark, and terrestrial law. And you can see here the sea level, the sea, and here are the coring sites. The pit is up to 5 meters thick. You can see here. Here you can see stratigraphic column. The pit is the most abundant organic sediment. the degree of communication is 5 to 8. It's a Pohn-Postel scale. It's about how much is humidified and is destroyed the organic material. You can see as we're going deeper, it's more humidified. We made some paleobotanic determinations, and we found that the pit has many residual tissues and fluids from Cladium mariscus. They like calciferous environment, they form, and there are some relics, also Calyx liparia and fluids from Ranunculus lingua. There are plants that they are like loofah, like that. And we found also Orgonia haracea. These are some laboratory testing. There is a pH measurement. It's slightly oxic, and the electric conductivity, we found it's many dissolved solids in the water, also in the pits. The ash, it's high. It's about 45%. And with the radiocarbon dating, we found sedimentation rates about 0.8 up to 1.2 millimeters per year accumulation. We made some other analysis, geochemical analysis, in order to see if it's influence of the sea during the pit accumulation, and we found there is in some periods multi-branchis conditions. Also, some other time there was fresh water. So we see that sometimes the seawater was coming into the fen, and some other time the fresh water was covered the area. This is some mineralogical results. We've done these X-ray diffraction diagrams to all of this section. So the major mineral are calcite, halite, chlorites, and elite mesenite clays, gypsum, and some iron oxides. We saw that cross section before. This is with this we based we make this cross section, and then we make this evolution of the Curie fen. So we have 6 different stages. At the first stage was a terrastic loam, and in the center part was a limnic environment. So before 2074 BC, they start peat accumulation there, and some mud, there's a mud there, and there was a lake at that time. So after that time, the peat formation was started with accumulated peat, and was covered gradually all the area up to now. And these days we have this appearance. All the peat is, all the area is covered from the pits, and it's dominated the area there. So some conclusions there. The Curie fen, it's in the Curie fen, pit started accumulated 4,070 years ago, and under the process of terrestrialization. In the western part of the fen was about 5 meters selenotomatic sediments accumulated, with a mean rate 1 millimeter per year. The fen water was supplied was rich in the calcium carbonate, and slightly acidic conditions were prevailed through this time. Increased plastic influx result in a high ash content of peat. Sea inundation took place during the peat accumulation, resulting in the establishment of middle brackish conditions. Thank you very much for
So I have some questions, please. The first question is, which kind of peat you have there? Is it referring to Magnatum or Carex or Mucus or Shelf? What kind of peat? The second thing, I am missing petrographical analysis of peat, which is the graduation rate. And third, the biological data, the correlation between the age and biological carbon dating and biological data. Fourth, the diversity of the asphalt. Which kind of asphalt? Can you tell me something about?
Yes, I can tell. So the pits. The pit is consisted mostly from Gladium mariscus and Carex and some Phragmites australis. So it's more calciferous. The water was rich in calcium, so it was more Gladium mariscus in the most of the
But
places.
in the south part also
In the-
Mucus.
We found also some humus in small spots, and in places that around in some ditches where some brackish waters, we found Aludodonax.
Yeah.
We didn't. Stavros will going to present details for petrological organic petrography tomorrow from Curie. So I didn't mention anything. We didn't make any of the asphalt any analysis because it was not our target. It was a target.
The asphalt, is the down, is casting system,
It comes from the faults.
it's casting system.
Maybe it's karstic, I don't know that because there are not so many details for these places. There are some surveys that are going now, happened in Greece. I don't know, there are secrets for us, so we don't know that yet. I don't know.
Because I've been 3 times there.
There are some wells, so there are some wells. I don't know how deep these are, the wells. We see this coming, they are gazing like spring from down, we don't know.
Very fine.
But-
What
but
about the dating, carbon dating and biology?
we have some, if you see here, there are some pollen assemblages, and there are some. We made three carbon radiocarbon dates. I have here the details. You see, it was started at that time. And at that time we had, according to the pollen zone that we measured, was mostly starting to be limnothermatic from limbic, and so we found Kipperacea and these spores. At that time we found the second zone, we found some Pteridophytes and Quercus and these spores, and at the 2 last stages there was dominating from more helophytic and